In this lesson, we are going to learn to divide by binomials, but we're doing it using long division. So this is for anyone who wants to learn it can. This is not a requirement of advanced algebra though. So if you are someone who plans to take calculus, this is something you need to be able to do. So that's why we're reviewing it now, because it's a good time to show it to you and introduce it. Just to get you started, I want to bring you back to when you used to divide in grade school. Let's take 3 going into the number 273. The first thing you would do is say, I don't like this number, sorry, I'm just making this up. Let me pick a better one. I want it not to work equally right away. There we go. My first thing I would say is how many times does 3 go into 2? It doesn't, so I move to the next place value. How many times does 3 go into 26? I would then pick 8 times, and I get 24 here. If you remember doing that, 8 times 3 is 24. Then I subtract here. So right here you change this to subtraction. 26 minus 24 is 2. And then you bring down this 3. How many times does 3 go into 23? That would be 7. 7 times 3 is 21. And I bring down my 2. This is my remainder, unless you were looking to write it in decimal form. But if I'm doing it with my fractions, this is my remainder. So I would say it goes in 263 divides by 3, 87 and 2/3 times. I'm getting the 2 from my remainder and the 3 because that's what I divided by. Those 3's are the same. So just as a quick review of how you do long division, we're going to apply that now with variables. So this is the same problem you did with synthetic, the first one yesterday. We would say, how many times does x go into x squared? So, or you could say, what times x makes x squared? So I'm going to say x. X times x makes x squared. So then I'm going to distribute this x to both terms here. So I'd have x times x is x squared. X times a negative 4 is negative 4x. I'm just going to get rid of this so we're not so full of stuff here. So now what I do is I found that first term. I'm going to then subtract here. So I have to change these signs to make that subtraction. These should cancel out. That was my whole goal there. And then when I add here, it ends up being adding. I have 6x, and then I'm going to bring down the minus 24. How many times does x go into 6x? Or what times x makes 6x? Well, hopefully you'll say 6. And it's a positive 6, so we write plus 6. And then again, I'm going to distribute this 6 to both of these terms. So I would come down here and have 6x, and then 6 times the negative 4 is negative 24. When I change those signs, I end up with a remainder of 0. Hopefully that makes some sense to you. It's something that when you do it with variables, it might take a little bit to get the hang of it, but it is done the exact same way you did in grade school. So my answer here is x plus 6, which is the same answer we got when we did synthetic. We'll just keep going and try a whole bunch more, just to keep getting the hang of it. So now in number 5, I'm going to have to write this one. So I have x minus 5 divided into x squared minus 2x minus 15. So now as I start, I say what times x makes x squared. Hopefully you see that that's x. So then distribute that x to both terms. I'd have x squared minus 5x. I draw my line. Remember, I'm subtracting, so I need to change those signs. So these add up, these right here cancel. That's my whole goal there. And then negative 2x plus 5x would be 3x. And I bring down the minus 15. What times x makes 3x? Positive 3. And then again, I distribute that 3 to the x minus 5. So I'd have 3x minus 15. Subtract, so I change those signs, and I end up with my remainder of 0 again. So my answer is x plus 3. Now if you're following along, these are the same problems we did when you did the synthetic lesson. They're the exact same ones. So you should see we're getting the same answers using synthetic and long division. Number 6, just like with synthetic, when I write this out, I'm going to leave a spot for the x squared. I don't have an x, or excuse me, for the x spot. I have an x squared. How about the x we don't have? So I'm copying that, and then I'm going to go plus 0x because I want to represent that place value. So then I ask myself, what times x makes x cubed? Well, that would be x squared. And I distribute that x squared to the x plus 2, so I'd have x cubed plus 2x squared. Then again, I'm going to change my signs because I'm subtracting. Draw my line. My x cubes are add up to 0, which is what I was hoping for, and I have negative 8x squared here. Then I bring down the plus 0x. What times x makes negative 8x squared? Negative 8x. And then I distribute that negative 8x to the x plus 2, so I'd have negative 8x squared minus 16x. Change my signs again. So I have 16x, and then I'm going to bring down this 1, plus 1. What times x makes 16x? That would be 16. And then I go ahead and distribute that 16 to the x plus 2. So I would get 16x plus 32. Change my signs, and I see that I have a negative 31 here. So just like with the last remainder when I did our problem from, or your reminder problem from before, I would have my remainder as a minus 31 over x plus 2. Where that came from, this is a negative 31, so that's why this is a minus right here. The 31 went there. This x plus 2 is what I was dividing by, so that's where that came from. Hopefully that one makes sense to you. And again, same answer we got when we did synthetic. Number 7, I have x minus 4, and then I have x cubed, and I'm going to go 0x squared, 0x minus 64. How many times does x go into x cubed? We would say it goes into it x squared times. And then I distribute that x squared to the x minus 4, so I get x cubed minus 4x squared. Change my signs because I'm subtracting. So I have 4x squared plus 0x I bring down. X times what makes 4x squared? 4x. So again, I distribute and get 4x squared minus 16x. Change my signs. So I have 16x minus 64 when I bring this one down. What times x makes 16x? That would be 16. Distribute. I have 16x minus 64. And change my signs. My remainder is 0. So that is my answer. Number 8. I have x minus 2 goes into x to the 5th, and then I don't have an x to the 4th, and I don't have an x cubed, but then I have an x squared. Extend my line there. I don't have an x, so here's a pretty good size one, right? There we go. It's a really bad divisor symbol there. So now, as I go in, I'm going to say what times x would make x to the 5th, and hopefully you can see that that would be x to the 4th. So then I distribute that to both. It'd be x to the 5th minus 2x to the 4th. Draw my line, change the signs. So I have 2x to the 4th plus 0x cubed. What times x would make 2x to the 4th? That'd be 2x cubed. Distribute that 2x cubed, I'd get 2x to the 4th minus 4x cubed. Change my signs. I end up with 4x cubed, and then I'm going to bring down this minus 3x squared. What times x makes 4x cubed? That would be 4x squared. Distribute that, I have 4x cubed minus 8x squared. Change my signs, because I'm subtracting. So I have 5x squared, I'm going to bring down my 0x, so plus 0x. Give myself a little bit more room here. What times x makes 5x squared? That would be 5x. Distribute the 5x, I get 5x squared minus 10x. Change my signs. I have 10x. And now I bring down my last term, my minus 20. What times x makes 10x? That would be 10. When I distribute, I get 10x minus 20, which when I change my signs, I get 0, just with a little bit of space left. So all of that work gave me my fabulous answer right here. No remainder. If you are someone who is planning to take calculus, you should choose to do this method now. You don't have to. I'm not going to force it down your throat because I don't know who's taking calculus and who's not, but it's really smart to get the hang of long division before you start calculus. It's something you will do in the first few months of calc, and if you know how to do long division, it's going to help you be ahead of the kids who don't. After this, though, I'm never going to require you to do a method. I'm going to let you choose if you do long division or synthetic. It's a personal choice, whichever one you like better. Later on, we'll have some where synthetic will make more sense, but I want you to know synthetic, but I'm not going to make you use it yet. Hopefully that helps. Let me know if you have any questions.